Okay. So intermediate and advanced SQL we are going to see now. In intermediate and advanced SQL, we are going to see join relations, okay, join part. Along with that, we are going to see the views and authorization. So these three topics we are going to see. So join already we have studied in relational algebra we have studied, and also the natural join operation in SQL we have studied. So the join is simply the Cartesian product of two argument relation, forcing equality on those attributes which are common in both the relation and remove the duplicate attribute, that we call a join operation. So it remove the drawback of Cartesian product, natural join is used. So that join part already we have studied, but here we are going to see in detail the join. Now see, join has takes two relation, join operation takes two relation and return as a result another relation as the any SQL operation. These additional operations are typically used as subquery expression in the from clause. Join condition and join type. There are two ways. Join condition. So what is join condition? Here defines which tuples in two relation match. So on predicate is there. So on, suppose which tuple which is common in both the relation, multiple tuples are there which are common in both the relation, then on which tuple we are going to match it. So that we can give it in predicate, and also what attributes are present in the result of join. So that we can give here using A1, A2 to AN, the attribute that we wish to appear in the result of join. So that is join condition. And join type defines how tuples in each relation that do not match any tuple in another relation based on the join condition are like this: left outer join, right outer join and full outer join. So the natural join that we have studied, it is same as inner join. Okay. Now we are going to see the outer join operation. So outer join operation already again we have studied it in relational algebra. For which purpose it is used? In join operation there may be loss of information. Means when we join two relations, it may be possible that we lose the information for some of the tuples. So to avoid this, we use the outer join operation. So outer join operation, it is an extension of natural join operation. It has three forms: left outer join, right outer join and full outer join. So it completes the join and then add the tuples from one relation that do not match tuples in the other relation to the result of join with null values, using the null values. So the example is given here. Suppose there are two relations. First one is the course and second one is the prerequisite. Suppose there are two relations. First one is the course and second one is the prerequisite. Then in this case, if we perform the natural join operation or inner join operation on this, what result we will get? We get, if compare this one with this one, as both are equal, we get this tuple. Then here this one and this value is equal, so we will get this value. But here we lose the information about CS315. Why? Because it does not match with any tuple in prerequisite. Also here we miss the information about CS347 as it does not match with any tuple in course. And that's why we miss this information when we perform the inner join of these two, natural join of these two, we miss the information about these two tuples. So how to deal with this loss of information? We use the outer join operation. Okay, so left outer join, right outer join and full outer join. So this part already we covered in the relational algebra, but again I am explaining it as a revision part. Left outer join. So takes all the tuples in the left relation, okay, that did not match with any tuple in the right relation, and pad these tuples with the null values for all other attributes from the right relation and then add them into the result of the join. So here in the previous case, the relation in the first relation, it takes all the tuples from the left relation that did not match with any tuple in the right relation. So which tuple is did not match with any relation in the right? This one. So it paired these tuples with the null values for those attributes which are from the right relation. So prerequisite ID is there. So here prerequisite ID becomes null and add these tuples into the result. So here it is added like this. Here 315 robotics title of the course, department name computer science, credits 3 and null value for prerequisite. Have you got? That is left outer join. What is right outer join? Opposite to that, it takes all the tuples from the right relation that did not match with any tuple to the left relation, add the value, null value for those attributes which are from the left relation and add this into the result. So here this tuple not match with any tuple in the left relation. And that's why here instead of this I am going to write it here. CS, sorry, course ID it becomes null. Then title, here there are only, sorry, course ID and prerequisite, not null. So CS 347, title is not there. The tuples from attributes from the left relation, title, it becomes null, department name becomes null, credit becomes null, and prerequisite CS 101 in this way. So that is right outer join. And what is full outer join? It performs both the tasks. It takes the tuple from the left relation that did not match with any tuple in the right relation. Also, it takes the tuples from the right relation that did not match with any tuple in the left relation, and then attach a null value for those attributes which are not available and add this into the result. So in this way. So for this, in this case, we get the information about CS315 and also we get the information about 3S, CS347. So that is full outer join. So that is the outer join operation which is used to deal with the loss of information. Next thing that, and I already told that to distinguish from the outer join and natural join we call it as a inner join. So distinguish normal joins with outer join operation, we call them as a inner join. Or you can use word natural join, anything you can use. So for example, select star from course join prerequisite using course ID. So using course ID means course ID is the attribute which is common in both the relation and that is matches with each other. So only two values we will get here. Why? Because 315 and 347 this does not match with any tuple in the left and right relation. And that's why we get only this using the simple join, or you can use here inner join, or you can use the natural join. Any word you can use, you will get the same result. But if you want the missing tuple, use the outer join, either full right or left outer join. So always remember the difference between these things. What is inner join and what is outer join. That is about the join relation. Okay, now we move towards the next, that is views. So views is normally used for security purpose. View is normally used for security purpose. So in C, it is not desirable that every person or every user see the entire database. For example, if we see our Moodle database, not necessary that students see the entire database. So student can see the data related to them only. Third year students only see the third year related courses. Final year students see only the final year related courses, and second year students see only second year related courses. As an instructor, I can see the courses which are allocated to me. Another person can see, or another instructor can see the courses allocated to him or her. But the administrator or HOD can see entire database of the Moodle. Why this is there? To provide the security. And the views is work in the same way. So in some cases, it is not desirable for all users see the entire database or entire logical model. For example, here one that there is a person who is interested for or require the data for ID, name and department name, not concerned with the salary. So normally in SQL, how we find out this value? Select ID, name, department name from instructor. Okay, so that information we will get here with this query. Now using these subqueries, we can create the views. So a view provides a mechanism to hide certain data from the view of certain users. View provide a mechanism to hide certain data from the view of certain users. So any relation that is not part of conceptual model, means original model, but is made visible to a user as a virtual relation is called view. View means virtual relation. Some cases, some databases, the information or the view is stored in the database, and in some it is not stored. Means it is virtually created only for the user. The values or whatever the view structure, it is not stored in the database. Have you got? So a relation that is not part of the conceptual model but is made visible to user as a virtual relation is called a view. So that is the simple definition of view. To hide certain information from certain users. Now how to create the view in the database? So for that, create view command is used. How to create the view in SQL? Create command is there. So view is defined using create view statement. Simple. Create view v is the name given to the view. And here any legal query SQL query expression. Any legal SQL query expression. So query expression is any legal query expression and the view name is represented by v. You can give any name depend upon the view you are going to create. Now see it with example. Okay, once the view is defined, the view name can be used to refer as a virtual relation to get the or retrieve the information. That view name we can use as a virtual relation to get the information. So we are going to see it with example. Okay. A view of instructors without their salary. If we want to create a view of instructor without their salary, means salary is not required in the view. Only the name of the instructors are required. So we are going to create a view. Any name we can give to that particular view. Not necessary the relation or the what we call the name which is equivalent or suit to your statement. So here we require the view of instructors without salary. So I can give the name as create view. I give the name here faculty as create view faculty. So faculty is the name given to the view. As now I need to write the expression, any legal query expression. What is given in the statement? We want the instructors without their salary. So which relation is required here? Instructor. So predicate is not given there. No predicate is given there. So create view faculty as select name, sorry, first ID, name and department name from instructor. So whatever the result of this query, that create a view with the name faculty. That is the simple way to create a view. Means what? What is the result of this? Here it creates a new virtual relation. Okay? It creates a new view or virtual relation with name faculty. And what are the attributes of this virtual relation? ID, name and department name. What is the attribute? These are the attributes. That is the new virtual relation. And this relation we can use to retrieve the data also. This virtual relation we can use to retrieve the data also. Means created view can be referred to find the information. Find all instructors in the biology department. So here using this view I can solve this query or I can retrieve this information. How? See here. Select what we want. All the instructors in the biology department. So select name from, instead of instructor, I am going to use the view which is created. Select name from faculty where department name is equal to biology. So from where this data is retrieved? It is retrieved from this faculty view, not from the original relation. Okay? Retrieve the data from this faculty, not from the original relation. So in this way, the created view we can use to retrieve the information. Okay? Now, create a view of every, some examples we are going to see here. Create a view of every department salary total. Create a view of every department salary total. So you can give the name as create view department salary total. You can rename the attributes by writing the name of new attribute in bracket as, and then you need to write a legal query expression. Okay, so I'm going to write that first. Suppose I give the name create view department salary total, and I want to give the name to the new attributes as department name and total salary. So these names are given to the new view which is created department total salary. Now I need to write here the legal query expression. What is there in the statement? We want the department salary total, or we want the department wise total salary. What we want here? Department wise total salary. So here the query select department name, comma, sum in bracket salary, aggregate function we need to write along with group by from instructor, group by department name. So the result of this query, it generates the view department salary total. Okay, it generates a view department salary total and rename it with these two attributes. So the result is like this: department salary total with the first attribute name, department name, and second one is total salary. So in this way, we can create the views according to the requirement of users. Okay. So here another example. Create a view that lists all course sections offered by the physics department in fall 2009 semester with building and room number of each section. So we want here the courses ID, section ID, then which taught the courses in fall 2009, semester and year is there with their building and room number. So here first I create a view with the name create view. Okay, physics department courses, you can say. What we can give the name? Physics department or physics fall 2009. As, and we need to write a query expression here. So which relations are required to solve this query? In the result, what we want? We want course ID, section ID, then we want building and room number. And what predicate is given? Semester is equal to fall and year is equal to 2009. What we want in the result? Select course ID, section ID, then building, room number from. Two relations are required here. In the section, course ID is there, section ID is there, semester and year is there. But there is no department name. Building and room number is also there in the section. In the section, course ID is there, section ID is there, semester is there, year is there, building is there, room number is there. The department name is there. So this section is not sufficient. Along with that, we need to use another relation which is related to the section, that is in the course ID and department name is there. So physics department course ID from where we can get? From the course relation. And that's why from course comma section, or you can write here natural join, or you can use the join operation to avoid one predicate. So if it is not there, first we need to write a predicate where course dot course ID is equal to section dot course ID. And another three predicates are given where department name is equal to physics and, sorry, not where, and department name is equal to physics and semester is equal to fall and year is equal to 2009. So here it completes the query. So it creates view physics fall 2009 as. So now course ID is there both in the section and course. So here we need to mention whether it is from the course or from the section as with the prefix, because it is there in both the relation. So in this way, if we can create the different views, but we need to write a proper query expression here everywhere. Otherwise, it creates the error. Now find all physics courses offered in fall 2009 in Watson building. So from this we can solve this query, correct? So how to solve this? Select what we want, course ID from physics fall 2009 where building is equal to Watson. So the query is like this: select course ID from physics fall 2009 where building is equal to Watson. So from this view, we solve this or retrieve this information. Okay, now the next part. Certain database, as I told that certain databases allowed to store the view structure in the database. Okay, some databases not allowed to store the view data database or view definition in the database, view structure in the database. These are created virtually whenever required and not stored in the database. But some databases allow the view relation to be stored, but they make sure that if any changes are made to the original relation, the view need to be updated. Suppose, for example, we are calculating total salary. Then if salary changes are there, we need to update the view also. Such views are known as materialized views. Such views are known as materialized views. See again, certain databases allow to store the view structure, but the original relation on which the view is generated, the view make the view update according to that. That is known as materialized view. So here the example is given for total salary. Suppose we create a view department total salary, that already we have seen. So department wise. Now suppose new instructors are added in the department. Then there is a change in we need to this is updated. Instructor is also updated there. Means here, as we use this sum salary here, whenever the original relation, instructor relation is updated, any insert, update or delete, the view also need to be updated. In the case of material views. Not audited. Okay. So, update of view or modification to the views. For example, suppose we want to add a new tuple into the view instead of original relation. Suppose we want to add a new tuple into the view. Then in that case, for example, I execute the query insert into faculty. What is faculty? Is it the original relation? No, it is the view. So insert into faculty values ID, name and department name. Then in the what happens in the original relation? This will be inserted but with null value for salary. This will be inserted in the original relation also but with null value for salary. That is the addition if we do with the views. Then another example is given here. Suppose we create a view about the instructor information, ID, name and building. Okay. From instructor department where the common attribute is department name. Instructor dot department name is equal to department dot department name. So what it gives? ID of that instructor, name of the instructor and where their department building is located. Okay. The building name of their department. So in this the result is 3 attributes: ID, name and building. Suppose this view is created and here we insert the value in this view. Insert into instructor information the ID of the instructor 69987. Then name of the instructor is White and the building is Taylor. And building is Taylor. Now there are two relations we considered for this view. Means this value is inserted into the instructor and also into the department. See once again. Suppose we create a view instructor information as with this ID, name and building of their department. With the help of two relations, instructor and department. And once view is created and after that suppose I execute this query, insert into instructor information values. So ID, this ID, then the name and the building. Now as there are two original relations on this view is created, this value is inserted in both the relation. Now see how it is inserted in both the relation and what is the result. So in the first instructor ID name, but there is no department name and salary, so both becomes null automatically. And in the department name, what happens? Null for department name, building, null for budget, but it is not allowed. Why? Department name is the primary key which we cannot insert null, and that's why that query which try to insert the value into the instructor information will not execute. It gives the error that violates the primary key constraint. So in this way, some of the cases we are allowed to update the information. Here it is possible, but here it is not possible. Why? Because it tried to insert the null value for the department name, which is the primary key. So that is about the modification or updation of the views. Okay, now we move towards the next part, that is authorization. The last part, authorization. So simple, how to give authorization to the particular user so that the user can see only or perform that only task. So different types of authorizations are there. In read, allows the reading only but not modification to the database. Insert, allow the insertion of new data but not modification of existing data. Update, allow the modification but not deletion of the data. Delete, allow the deletion of the data. Then the forms of authorization for modification of schema. These are the only data modification. Insert, update, delete, tuple. We can insert that, author can insert the tuple, delete the tuple or update the tuple. And the authorization also there for modification of the schema. Means he can create the index or delete the index that particular authorized person. Resources allow the creation of new relation. He can create a new schema. Then alteration allow the addition or deletion of the attributes in a relation and allow the dropping of relation. Means here these are the authorization related to the database schema and these are the authorization related to the actual data which is stored in the database. Tuple. And that we call as a privilege. These authorizations are known as privilege given to that particular user. So, the grant statement is used to confirm the authorization. The simple syntax, grant privilege list on relation name or view name to user list. Privilege list means allow the granting of several privileges with comma. Means for a particular user, if allow the insert and also delete both privileges. Then relation name means on which relation that authorization is given. Privilege is given. User is the user list. So ID may be given there, login names may be given there, whatever, according to the organization. So a user ID to whom the authorization is given, that is user list. Again, multiple users you can give the authorization with the comma. And instead of this, suppose I write here public, then it is allow for all current and future users of the system. If I write there public, who a person who creates the relation, generates the schema, he has given all authorization. The person who creates the schema has given the insert, update, delete, modification, any kind of authorization. Next, select. Select or read. In some cases, read is there. in some cases select is there. Select is only to retrieve the information, to access the information from the database. So example is given there. Suppose we want to grant the users U1, U2, U3 the read authorization for the instructor relation. So how it is written? Grant select. So select is the privilege. He can only read the information, not anything else. On which relation? Instructor to which users? U1, U2, U3. These are the user ID. So U1, U2, U3, these three are only allowed to read or select the information from the instructor. They are not allowed to insert, update or delete. So insert to insert the tuples, update to update the tuples. For example, for particular attribute, we want to give the privilege of updating. So how it is? Grant update on budget only. On department to Amit and Satoshi. So Amit and Satoshi can only update the budget, no other tuple. Or sorry, no other attribute. Amit and Satoshi can only update the budget attribute from the department. If it is not there, then they can update all the attributes of the department, name, building and budget. Then delete, to delete the tuples, all privilege if it is written there, then the user can do anything, insert, update, delete or select. Revoke. So the revoke statement is used to revoke the authorization. If it is given and so after some days the administrator want to revoke that authorization, the administrator can revoke this authorization by using revoke. So revoke privilege list, the privileges which are given. Suppose four privileges are given there, select, insert, update and delete. And the administrator want to revoke only two, that is update and delete. So you can do that. So privilege list, update and delete. Okay, on relation, whatever the relation or the view name and from the user. So the user now not possible to update or delete the information from that tuple, from that relation. Why? Because their authorizations or privileges are revoked. Revoke select, for example, revoke select on branch from U1, U2, U3. Means they are not allowed to read the information also because that authorization is revoked. If user list include public, all users lose the privilege list, whatever the given, if it is public there. So roles also we can create in the database using the statement create role. Okay, roles you can create and you can give the privileges to that particular roles which are created. So a set of roles is created in the database. Authorization can be granted to the roles instead of that user. To that role is authorization given. So once that role is created, authorization is given, that person can use that particular database in exactly same fashion as they granted the individual. For example, in university database, different roles we can create such as instructor, teaching assistant, student, dean, department chair or HOD. So in this way, the roles we can create in the database. Any authorization that can be granted to a user can be granted to a role also. For example, how to create the role? Using create role instructor and grant instructor to Amit. Means now Amit is instructor. Amit is instructor. Create role HOD. Grant HOD to XYZ. So now XYZ is HOD. Role given to that HOD. So role is first created and then the particular person is assigned to that role using the grant statement. So roles can then be granted to privilege. For example, grant select on text to instructor. So whoever the instructor, suppose there are 10 instructors. Okay, so suppose there are 10 instructors, then all the instructors, this select privilege is given. Suppose there are 10 teaching, 20 teaching assistants. So that privilege is given to all teaching assistants. Why? Because that role is assigned to 20%, that role is assigned to 10%. So all that 10, 20 persons can use this privilege. Can use this privilege. Okay. So in this way, we can create the roles, we can assign the roles to multiple persons and directly grant that privilege to that role. So whoever the instructor in the university has privilege, select on text. Another example is given here. Create role dean, grant dean to Amit, grant instructor to dean, grant dean to Satoshi. Now the Satoshi is dean. He is also the instructor and he can use all the privileges whatever given to the instructor and dean. So in this way we can create the role and we can give the privilege. That is about the authorization.